Scientists have just discovered something very strange about the universe. New pictures recently received from the James Webb telescope have revealed something unusual about the universe, which shows that something very strange existed even before the Big Bang. Renowned scientists worldwide are now warning that these discoveries could challenge and even overturn our current understanding of the universe.
Well, Einstein says the universe is a bubble. We live on the skin of the bubble, and the bubble's expanding. That's called the Big Bang Theory. String theory says there are other bubbles out there. There's a bubble bath of universes. Big bangs are happening even as we speak. So we have this bubble bath of universes. Right. So there was something before the Big Bang.
Your model isn't, is it a Big Bang model with an initial emergence out of nothing and then eventually a collapse back to that?
No.
No. So, okay, so how do you conceptualize that?
Well, first of all, it is a Big Bang model. In other words, there is a Big Bang, but the Big Bang was not the beginning.
We have a well-established idea of how the universe evolved after the Big Bang, how the first stars, galaxies, and black holes formed. However, a major question remains: what existed before the Big Bang? But now it seems they found the answer to it, but it has left scientists shocked, as the findings from the Webb telescope suggest that something unusual might have existed before that event, hinting at gaps in our standard cosmological models. So, what did we just find, and how did it surprise astronomers around the world? When scientists first studied distant galaxies in the 1920s, they made a surprising discovery. They observed that most galaxies are moving away from us. Initially, this led some to speculate that Earth might be at the center of the universe. However, further observations showed that while most galaxies are receding, some, like the Andromeda Galaxy, are moving toward us. This seemed puzzling at the time. After decades of detailed observations and research, scientists realized that it's not the galaxies themselves moving through space, rather, space itself is expanding. While this expansion is not as simple as it seems, it has no fixed point, which means that wherever you stand in the universe, you will see that everything is moving away from you, as if each point is the center of the universe. This discovery led to the understanding that the universe has no fixed center, everything is moving away from everything else due to this cosmic expansion. Scientists have also observed that space is not only expanding, but it is accelerating, which means that the farther a galaxy is, the faster it is moving away from us. And in recent observations, scientists have confirmed that 97% of galaxies in the observable universe are moving away from us faster than the speed of light. But how can this be true when one of the fundamental laws of physics is that nothing can travel faster than light? Well, the answer lies in understanding Einstein's theory of special relativity. This theory states that nothing can move faster than light through space. However, as I have just mentioned, distant galaxies aren't moving away from us through space. Instead, the space between us and them is expanding. This expansion of space causes the distance between us and these galaxies to increase faster than light could travel. In other words, it's not the galaxies themselves speeding away, but the space itself stretching. Therefore, they're not breaking any cosmic speed limits, they're simply being carried along by the expansion of the universe. Scientists believe that this expansion of our universe might have started with the Big Bang itself. Before the Big Bang, there was no space, no time, and no matter as we know it. The Big Bang marks the birth of our universe and the beginning of time and space. When we talk about the Big Bang, we usually think of it as the moment and the universe exploded into existence, expanding from a tiny, hot point into the vast space filled with stars and galaxies that we see today. Now, according to our standard cosmological model, about 14 billion years ago, our entire observable universe and everything beyond it that we can't see would have compressed into a tiny, infinite point we call the singularity. You might think of this singularity as a single point in space, but that's not true. I mean, that would be true if the universe is finite, but if the universe is infinite, and it kind of looks like it is, then it was always infinite. So, the Big Bang did not occur at a particular point in space, but rather it occurred everywhere. This means that the first galaxies did not form in any particular region of space, they formed everywhere in the universe, even beyond the observable universe that we cannot see. It seems as if matter came into existence everywhere in the universe at a particular time. But the Big Bang on its own doesn't explain everything, like why the universe looks the same in all directions or why it's so flat and spread out. Take a telescope and start looking in different directions, roughly speaking, it looks the same. This is where the idea of inflation comes in. Inflation suggests that just before the Big Bang, the universe went through a period of incredibly rapid expansion. In less than a trillionth of a second, it stretched from a tiny size to something much larger. This inflationary expansion was driven by a strange kind of energy that was present in empty space. But this empty space wasn't empty like we usually think. Instead, it was filled with this special energy that pushed space to expand at an incredible speed. The universe is not expanding into some pre-existing container. Before this rapid expansion, the universe was extremely cold and nearly empty. There were no stars, galaxies, or even particles, just a cold, dark, empty void. However, this void wasn't truly empty because it had this inflationary energy that stretched the universe out. During this expansion, any lumps or irregularities in space were smoothed out, making the universe appear flat and uniform when we look at it on large scales today. Once this inflation ended, all the energy that had been stored in space was released. This sudden release of energy heated everything up and triggered what we now call the Big Bang, the hot, dense explosion that filled the universe with particles, light, and everything needed for galaxies, stars, and planets to eventually form. This idea of inflation not only explains why the universe looks the way it does, but also tells us that before the Big Bang, the universe was a cold, empty space that rapidly stretched out due to this strange energy. This stretch laid the groundwork for everything that would come later. However, while inflation answers some big questions, it also raises new ones. For example, what exactly caused this inflation to start and stop, and what was this mysterious energy that drove it? But here we're talking about the whole universe. There's nothing outside the universe to bring it into existence. Well, new discoveries from the James Webb Telescope have raised many more questions. These new discoveries are revealing the existence of strange things before the Big Bang. The James Webb Space Telescope has recently made a surprising discovery. It found that the universe is expanding at different rates in different directions. This is a big deal because, until now, scientists believed that the universe's expansion was uniform. The theory of cosmic inflation, which suggests that the universe expanded rapidly due to vacuum energy before the Big Bang, also supports the idea that this expansion should be the same everywhere. But if these new findings from the Webb telescope are true, it will challenge our understanding of inflation and raise the question, why is the universe expanding differently in different regions? Is there something beyond dark energy influencing this uneven expansion? Dark energy is thought to be responsible for the accelerated expansion of the universe, but recent Webb telescope discoveries suggest there might be more we don't understand. It could mean that something unknown is influencing how space expands in different directions. On top of that, scientists using the Webb telescope have observed thousands of mysterious red dots in the deep field images it captured. At first, they thought these might be distant galaxies, but they're showing strange properties that don't match what we expect from early galaxies based on our current models. These objects behave in ways that challenge our understanding, hinting that there might be some unknown types of objects that existed in the early universe. These findings are significant because new evidence suggests that something existed before the Big Bang, and that something very strange might have happened before the universe we know came into being. When you look at this image, there are lots of splodes all over the place. What made you look at that one in particular? We have been seeing this object already in the very early days when we obtained images nearly 2 years ago. And I think the surprising thing was that it's actually very bright. And so our initial reaction was that, well, it cannot be that distant because, it's too bright. So we took better data, and in particular, we also took spectroscopy, and we could clearly see that, no, that galaxy, this yellow blob here, is really, the most distant galaxy that we have ever seen. Nobel-winning scientists and experts are now saying that our current understanding of the universe might be missing a crucial piece. The Standard Model of Cosmology explains the evolution of the universe from the Big Bang onward, but it doesn't fully address what came before. The new observations made by the Webb telescope are hinting that there could be more to the story, something that happened in a cold, empty space that existed before the universe expanded. These discoveries also challenge the traditional inflation theory, which states that a burst of rapid expansion driven by vacuum energy set the stage for the Big Bang. If the universe was truly shaped by this smooth, uniform inflation, why are we now seeing signs that the universe is expanding at different rates in different directions? It suggests that something more complex might have been happening before the Big Bang, affecting the universe in ways we're only now beginning to glimpse. In addition to these expansion anomalies, the Webb telescope has detected strange objects in the early universe that don't fit into our existing models. These findings indicate that the early universe might have been more diverse and mysterious than we thought. All of this evidence points to the possibility that the Big Bang wasn't the absolute beginning, but rather a transition from something else, something we still don't fully understand. As scientists continue to analyze these findings, they are increasingly open to the idea that our current theories might need major revisions. The possibility that there was a pre-Big Bang era, where different forces or conditions shaped the universe, could revolutionize our understanding of cosmology.